be looking at converting units of volume instead of units of area. This is going to be very similar to the last video, except we are going to be cubing our conversions instead of squaring them. So the first thing we're going to do is determine the number of cubic inches in 1 cubic foot. So we're going to start with 1 cubic foot over 1, and we're going to convert it to inches. So we want feet on the bottom, right? There's going to be 1 foot. There were 12 inches in 1 foot. So just like before, we are going to have to take this to a power, but this time it is going to be to the 3rd power. So we're going to cube it. So let's see what 12 cubed is. 1,728. So that's 1,278 inches cubed. Let's keep looking. Now we want to determine the number of cubic inches in 1 cubic yard. So we know how many cubic inches are in 1 cubic foot, right? So we can take this information and transfer it into our next problem. So we have in 1 foot, there are 1,728 cubic inches. Per 1 cubic foot. Now we're going to multiply that, and we are going to convert our feet into yards. Right now our feet are on the bottom, so we're going to put our feet on the top. So we're going to have 3 feet per 1 yard, but we're going to cube that whole thing. 3 cubed is 27, so I'm going to take what we got in our last answer and multiply it by 27. So that we get 46,656 inches cubed. That is quite a big number, but it is accurate. All right, based on a true story, a friend at the National Guard base gave us 3 long wooden crates to use as raised planting beds. The crates probably carried some kind of weapons or ammunition, but our friend wouldn't say. Henry, who was taking geometry in high school, was asked to measure the crates and figure out how much soil was needed. The inside dimensions of each crate were 112 inches long, 14 inches wide, 14 inches deep. We want to fill them most of the way full with soil, leaving about 4 inches empty on top. How many cubic yards of soil did they need to order from the supplier? So we want everything is perfectly legitimate, 112 inches long, 14 inches wide, but they only want 4 inches empty on top, so we're going to go 10 inches deep. So we have 112 inches by 14 inches by 10 inches. So let's see how much that is. 112 times 14 times 10 equals 1,500 or 15,680 inches cubed. But we have 3 crates, so we're going to have to multiply this whole thing by 3. Let's enter that again. Sometimes the calculators can be kind of funky after you hit enter. Times 10 times 3. So our total is going to be 47,040. So again, that times 3 comes from the fact that there are 3 crates. So we're going to do times 3 equals 47,040. So that's how many cubic inches of soil we need. We want to figure out how many cubic yards that is. So we're going to multiply that. So this is inches cubed. We're going to multiply that by feet. So we have inches on top. We want inches on the bottom. We have to cube that whole thing. Running out of space. We also have to multiply that to get rid of the yards. So we are going to have in 1 yard, 3 feet. That's going to be cubed. So we are going to divide this whole thing by 12 cubed. And then we are going to divide it by 27. And we get about 1 cubic yard, maybe 1.01. So continuing our true story, we decided to check our answer and did a rough estimate by rounding each dimension to the nearest foot, and then figuring out the volume from there. Did this give the same result? So let's take a look here. 112 inches, what is that to the nearest foot? So that's 112 divided by 12 for changing it to feet. It's about 9 feet. So we got 9 feet. And then 14 inches is about 1 foot, if we round. And 10 inches is about 1 foot. We got to multiply it by 3 because there are 3 crates. And we get 27 cubic feet. Now we have to convert that to cubic yards. We get 27 times, we need feet on the bottom, 3 feet for 1 yard. Cube that whole thing, and we get 27 divided by 3 cubed. 3 cubed is 27. So essentially, it's 27 divided by 27 is 1 cubic yard. So yes, that does give us approximately the same result. Let's look at our next problem. A standard US soda pop can has a diameter of 2.5 inches and a height of 4.75 inches. Verify that the can is able to hold 12 fluid ounces of liquid. So we need to convert well, first of all, we have to figure out what the volume is in inches. So let us do that. So the volume of a cylinder, a can is a cylindrical shape. We are going to have the diameter. We need the area of the base. So we use the diameter, which is pi r squared. So we need to change the diameter into a radius. 2.5 divided by 2 is 1.25. Pi times 1.25 squared. We multiply that whole thing by the height, 4.75 equals, we can take an approximation of pi, that's just fine. So 3.14159 times 1.25, 1.25 squared times 4.75. So we get 23.316 cubic inches. So how do we convert this into fluid ounces? This, I would simply use Google. So let's pull up Google. Cubic inches to fluid ounces. So there is 0.554113 fluid ounces for 1 cubic inch. 0.554. I'll have to come back to that. So 23.316 inches cubed times, we're going to want cubic inches on the bottom for 1 inch cubed. We have 0.554113. This is a legitimate strategy that you can use in your quizzes and exams if you have any quizzes. Definitely you can use them in your exam. Just be able to do it quickly. Don't spend a whole ton of time Googling. So we're going to take what we got in our calculator and we're going to multiply it by 0.554113 and we get 12.9 ounces. So we can determine now that a soda can hold up to 12 fluid ounces. It can actually hold an additional 0.9 fluid ounces, which is most likely just air. So let's look at our next problem, problem 6. We are going to convert 1,000 cubic feet into cubic meters. This is going to be another one that I'm going to use Google for. So we have 1,000 feet cubed over 1 times how many meters are in a foot. Again, I don't want you having to go to your notes every time you have one of these. So go ahead and use Google anytime you want. So there are 3.28084. Cubic feet, or sorry, just feet in 1 meter. So we're going to cube that whole thing, pull up the calculator, 1,000 divided by 3.28084 cubed. And we get about 28.3. And that is meters cubed. Now we want to convert 45 meters cubed to yards cubed. So we have 45 divided by 1 times, let's see how many meters are in a yard. .9144. In 1 yard. We have to cube this whole thing. And we're going to approximate. So let's pull up our calculator again. 45 divided by 0.9144 cubed. And we get about 58.9 yards. right, let's keep going. The standard size of a gold bar in the US Federal Reserve is 7 inches by 3 and 5/8 inches by 1 3/4 inches. The density of gold is 0.698 pounds per cubic inch. How much does one gold bar weigh? So this is going to be an interesting conversion. So we know we can figure out what the cubic inches are. And then we know how many pounds per cubic inch it is. So let's start by figuring out the dimensions. We have 7 inches by 3 and 5/8 inches by 1 3/4 inches. So let's take a look at that. 7 times 3 and 5/8 times 1 3/4. Might be easier to convert these into decimals to put them in your calculator. So let's do a reminder on what 5/8 is. So 5 divided by 8 is 0.625. So this is going to be 7 times 3.625 times 3/4 is 0.75, 1.75. Much easier way to figure this out. So we have 7 times 7 times 3.625 times 1.75. And we get 44.40625. Don't cut off the decimals quite yet because you want to round at the very end to get the most accurate answer. 44.40625. Now we have to convert inches cubed Oh, sorry, my computer's going crazy again. Typical, right? Inches cubed. And we have to convert that into pounds. It is, silly computer, times, we want cubic inches on the bottom, and it is 0.698 pounds per cubic inch. So we're going to multiply what we got here by 0.69816. Now it's appropriate to round. We can say it's about 31 pounds. I'm going to put my answer in red because my work got a little muddled. 31 pounds. And that's how we got it. So we got the volume in cubic inches. We converted cubic inches into pounds given this. And that's how we got our 31 pounds. Keep looking. Number 9. This should be our last set of problems here. A ping pong ball has the diameter of 4 centimeters. Wiffle ball has a diameter of twice that of a tennis ball. Interesting. So first off, I see diameters. All of our formulas have to do with radius. So if a ping pong ball has the diameter of 4 centimeters, its radius is going to be 2. A wiffle ball has a diameter of twice of a table tennis ball. A table tennis ball is a ping pong ball. So twice the diameter would be 8 centimeters. So the radius for that is going to be 4 centimeters. Determine the volume of a wiffle ball. So again, as opposed to going back and searching for these formulas, let's look up the volume of a sphere. And it is 4/3 pi r cubed. So that's what we're going to use. 4/3 pi. Our radius for the wiffle ball is 4, and we're going to cube it. So 4 to the third times 4 is going to be 4 to the fourth. So that's what I'm going to do. 4 to the fourth divided by 3 times 3.14159. And we get about 268 cubic centimeters. Now let's determine the volume of the table tennis or ping pong ball. Same setup. This time we're going to do 2 cubed. So 2 cubed is 8. 8 times 4. 8 times 4 divided by 3 equals times pi. 3.14159. And we get 33.5. And that's just an approximation. What is the ratio of these two balls? So let's take our first one, our wiffle ball, divided by, and we're in centimeters cubed, divided by 33.5 centimeters cubed. We're in centimeters cubed over centimeters cubed, so we don't have to do any cubing of anything. So 268 divided by 33.5, we get 8. So it is an 8-to-1 ratio, where the wiffle ball is the 8, the table tennis or ping pong ball is the 1. How might we have also figured this out? Well, let's take a look at our initial equations here. We have 4 cubed, we have 2 cubed. Everything else is the same, right? So what's the ratio of 4 cubed? Oh, it didn't like that. 4 cubed to 2 cubed. Well, 4 cubed is the same as 2 cubed times 2 cubed. These would cancel and we get 8. 2 cubed equals 8. So we still would get that 8-to-1 without having to use larger numbers. So 2 different ways of getting at the same solution. I highly encourage that line of thinking. Go ahead and work on the student-led examples. They should be extremely similar to the ones that we just worked on. Good luck.